Good morning. Welcome to geometry class. From this week's lesson, angle measures and segment lengths from textbook pages 790 to 794. Before we start, I want you to prepare the following: your geometry textbook, your pen, and your copybook.
Find the value of x. Here, we have two chords that intersect. When two chords intersect, it forms a pair of vertical angles. Notice, angle x is one of these vertical angles. Now, there's a special relationship between the measures of those vertical pairs of angles and the measures of the arcs that are intercepted on the circle. Let's begin then by first recalling what that special relationship is. It is that intersecting chords form an angle whose measure is half the sum of the measures of the intercepted arc. In other words, the measure of angle DEC is equal to 1/2 the sum of the measures of the intercepted arcs. So, the measure of arc AB plus the measure of arc DC. Now take a look. We know the measure of arc AB. It's equal to 68 degrees. We also know the measure of arc DC. It's equal to 96 degrees. And the measure of angle DEC, well, that's the measure of angle X. That means we're ready to go ahead and plug in and solve for X. The measure of angle DEC, well, it's the measure of angle X. So we can say X is equal to 1/2 the measure of arc AB, which is 68 degrees, so 68, plus the measure of arc DC, which is 96 degrees, so plus 96. Now that we have our equation, we're ready to go ahead and solve for X. So let's go ahead and do that. Notice, X is already isolated, so we just need to simplify the right-hand side of the equation. Well, X is equal to 1/2. 68 plus 96 is equal to 164. So 1/2 times 164. 1/2 times 164 is equal to 82. That means X is equal to 82. So now we know X is equal to 82.
In this problem, you will find measures of angles formed by chords, tangents, and secants. Part A. What is the value of x? Two chords intersect to form an angle with measure x degrees. And the degree measures of the intercepted arcs are 46 and 90. Use theorem 1213. Remember, theorem 1213 states that the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. Now simplify. So x equals 68. Part B. What is the value of z? A secant and a tangent intersect outside the circle to form a 20-degree angle. And the degree measures of the intercepted arcs are 95 and z. Use theorem 1214. Remember, theorem 1214 states that the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intercepted arcs. Multiply each side by 2. Add z to each side. Then subtract 40 from each side. So z equals 55.
Let's find the measure of arc MP. Taking a look at our diagram, we can see that arc MP is right here. That's what we want to find the measure of. Well, to do that, let's take a look at what we have. We've been given a circle, and we have intersecting line segments. You know, when lines intersect, we get vertical angles. These angles that sit opposite each other are the same, and this pair of angles that sit opposite each other also measure the same. Now, when we have lines intersect inside a circle, like we have, those are actually intersecting chords. And if we recall what we know about intersecting chords, it turns out that not only do we get those vertical angles, but those angles share a special relationship with the intercepted arcs. Let's take a look. If we look at just one of these angles, say this angle, MEP, that angle is actually the same as the average of the corresponding intersecting arcs. So, arc MP and arc QN. If we find the average of those arcs, that's the same as this angle measurement. And it would actually be the same as this angle measurement, since those are vertical angles. And we could do the same thing with either one of these angles, taking the average of arc MQ and arc PN. But think about this. We want to find the measure of arc MP. If we include arc MP, we need to include arc QN. If we take the average of those arcs, we will get the measure of this angle, or this angle, since again they measure the same. Since we already have the measure of this angle, let's take a look at that one. So that would be the measurement of angle QEN. That is equal to the average of arc QN and arc MP. Well, since there's only two arcs, to take the average, all we need to do is add those measurements together and then divide by 2, or multiply by 1/2. So, if we add those arc measurements together and divide by 2, or multiply by 1/2, we'll get the measure of angle QEN. We already know some of these measurements. So, let's go ahead and plug them in. Let's see. We have the measurement of angle QEN, 85 degrees. So let's write that down. Then we also have the measurement of arc QN. That measures 103 degrees. When we plug all these pieces in, all we're left with to find is the measurement of our arc MP. So all we need to do is solve for that arc and we will have our answer. Well, if we take a look, we're taking this side and multiplying it by 1/2. If we want to move this 1/2 to the other side, we can multiply both sides by the reciprocal of 1/2. 2, just 1/2 flipped over. So we multiply both sides by 2. 2 times 85 is 170. So we have 170 degrees. Here, 1/2 times 2 just gives us 1. So we're left with 103 degrees plus the measurement of arc MP. We're trying to get this piece by itself on one side. So we want to take this 103 degrees and move it to the other side. To do that, we can use the subtraction property of equality and subtract it from both sides. When we do, we get 67 degrees over here, and these two cancel out, and we're just left with the measurement of arc MP. That's what we were looking for. So we have now found that arc measurement we were looking for. We have found that the measurement of arc MP is 67 degrees.
In this problem, you will find an arc measure. A satellite in a geostationary orbit above Earth's equator has a viewing angle of Earth formed by the two tangents to the equator. The viewing angle is about 17 5/10 degrees. What is the measure of the arc of Earth that is viewed from the satellite? Theorem 1214 states that the measure of an angle formed by two lines that intersect outside a circle is half the difference of the measures of the intersected arcs. How can you represent the measures of the arcs? The sum of the measures of the arcs is 360 degrees. If the measure of one arc is x, then the measure of the other is 360 minus x. Let the measure of arc AB equal x. Then the measure of arc AEB equals 360 minus x. Use theorem 1214 to write an equation to find the measure of each arc. So 17 5/10 equals 1/2 times the difference of the measures of arc AEB and arc AB. Substitute 360 minus x for the measure of arc AEB and substitute x for the measure of arc AB. Now simplify. Use the distributive property. Now solve for x. A 162 5/10 degree arc can be viewed from the satellite. First, identify the parts of the diagram to help you determine which theorem to apply. You have circle N and two secants. Theorem 1215 has a case that relates the lengths of secants and their outer segments. How can you identify the segments needed to use Theorem 1215? Find where segments intersect each other relative to the circle. The lengths of segments that are part of one line will be on the same side of an equation. Use Theorem 1215, Case 2. Remember, Theorem 1215, Case 2 states that the products of the lengths of the secants and their outer segments are equal. Simplify the left side of the equation. And use the distributive property on the right side of the equation. Subtract 49 from each side. Now divide each side by 7 to solve for y. So y equals 5. Part B. What is the value of z? Again, identify the parts of the diagram to help you determine which theorem to apply. You have circle in, and you have a secant and a tangent. Use theorem 1215, case 3. Remember, theorem 1215, case 3 states that the product of the lengths of a secant and its outer segment equals the square of the length of the tangent. Simplify the left side of the equation. Then take the positive square root of each side to solve for z. So z is approximately 13 9/10.
Thank you for listening. If you have any questions, just send it through Schoology. Have a good day.